Yeah, so welcome to this presentation about our program, the Health Matrix Tracker. And the team behind the program is me, Jesper.
And me, Soravit.
And me, Surathan.
Me, Whisarut.
And here's a short description about the program. The Health Matrix Tracker is a program that allows people to check different health variables such as BMI and height, blood pressure and cholesterol in relationship to other people, ages, and different regions. This program can take in the following input: BMI, height, blood pressure and cholesterol, age, and region of choice.
A feature user-friendly interface for data input, automatic marker placement for the user, data point within the graph. Graph generation feature that display data points for the select metric age group and region. And next.
Scope. Objective of the scope would result in the user being able to see how their different health factors have changed throughout the years. Functions, there will only be 4 variables that the user may test. That those are the following: BMI, height, blood pressure, and cholesterol. By the way, the data is also limited to the years the data was collected and accessed, which in the case is 2016. The next feature is about weight or sugar level and can be introduced as well as compared to other groups, for example, genders. As you can see from the picture, the largest group is entire population. The second is specific region, and the smallest group is specific age group.
For the main flowchart of the program, first, it will show the option that may allow user to choose between BMI, height, blood pressure, and cholesterol. Then you can choose, there's a 5 option. The option BMI, height, blood pressure, and cholesterol, and quit. If you choose any option, this will have a detail that you need to input different in any option. Then the program will show us the display of each option. Next.
Yeah, so now we'll go into the different subroutines, and we'll start with the BMI, which I wrote. And the BMI data consists of 2 data frames or CSV files. And first the world CSV file, and then you have country-specific CSV file, and they are identical except that the country is, of course, not world, it's the chosen country. And we have variables such as gender, and we have year from 1975 to 2016, and you have the different percentiles, so we can make a histogram out of it if we want to, which we will. In total, the data is more than 16,000 rows, so we have a lot of countries and a lot of years. It's a lot of data. Yeah, so here is the flow chart. So basically, when you have chosen the BMI, it will ask you, do you want to compare your BMI or 2 regions' BMIs? And if you want to compare your BMI, it will ask you, do you want to see the different regions we have? And if you say yes, it will show the regions and then take you basically to the input. And the input for your BMI is region, gender, height, and weight. And once that is done, it will calculate your BMI, and it will put everything in a user data file that is then saved. So you can go back and check your data file if you want to check your progress or something like that. And then it will display the BMI and the chart. And if you don't want to check your BMI, you maybe want to check the historical BMI between different countries. This looks the same. It asks you want to see the regions, and if not, it will just ask you to choose the first region and then the second region, and then what gender you want to look at, because the gender BMI is very different. Girls are usually a bit lighter. And then it will display charts. And the result will look something like this. We will give an example later on when we run the program. So here's the Thailand and the global histograms, and then based on your BMI, it will highlight a column. So for this, in Thailand, I'm in this column, and in the world, I'm in this column, and we can see that they are a bit different. Yeah, and if you want to compare two regions, it will look something like this. So here we compare Sweden to Thailand, and we can see how the development throughout the years has changed the BMI. And now we'll go into the code. And I have just started up the program, so we don't have to wait for it. And this is the main program, and will look the same for all the program, for all the subroutines, of course. So here, which variable would we like to check is what it's asking, and we will want to check the BMI, and it will ask, would you like to check the BMI in relationship to other regions, or would I like to compare the historical progress of BMI between two regions? And we will go with the first one. We will calculate our BMI. Yeah, and choose a location. Do we want to see what are available? Yeah, sure, we can do this. And then here we see all the regions, and it's not case sensitive, so you can write however you want to. So let's say that I want to Thailand. Yeah, and it found Thailand, and then I'm a male, 1.77, and then 85 kilograms, and then there's my BMI. And we will go to the, and here is our histogram in 1 second. Yeah, and here is the histogram of Thailand, and you can choose any country that's available, of course. And the last thing is that this has been this wrote to this file. So here is our saved gender, and then the BMI, height, and weight. So you can track your progress if you want to. So let's go through the code. Just a quick version of here, check of the main. So we import all the important stuff, and then it asks what variable we want to check, and then it will go through. You can either enter BMI, or you can enter 1, and this is the same for all the subroutines. And now let's go into my specific subroutine. So we import all the different libraries. Matplotlib is for the historical change, and Plotly Express is for the histograms in general. I think Plotly looks a bit better. We start with importing everything, and then we remove the unnecessary columns, because it will just make everything faster if we don't have too much data, because we already have a lot of data. And if you want to check your BMI, it will collect the user data. So basically, do you want to, everything we saw there, do you want to check region? And if it doesn't find the region, it will print out all the available regions, and then it will ask you to choose one of those regions. So it should be a bit fail-safe. Edit safe is what we're aiming for. Anyone should be able to use it. And then it asks for gender, and then your height. And then here we write the data that we have collected to the file that I showed later, and then it specifies you in a BMI column, so you can print it later. And then basically we define the data frame based on year and gender and region, and then here we just plot it. Yeah, with the different labels and everything that's necessary. And then we have the second function, that's the compare function, and if you want to compare to different regions, so it's the same thing. You want to know what regions are available, and it does this twice, and nothing special there. And then we have a lot of these types of blank spaces to make the code more readable. Yeah, specifies your gender, and then your location, of course, if you're in a country or in the world. Basically defines two data frames, data frame 1 and data frame 2, which then they will compare. So yeah, plot data frame 1, the different variables, and then data frame 2 and the different variables, and then we plot it. So that's the BMI subroutine. And now we'll go on to the next subroutine.
Okay. Okay, next is tables of data of height. In the first one, that is height underscore versus v5. It will import a sex, year, age group, and mean height. In a sex, that will be boys and girls. In year, it will import 1985 until 2019. Age group will be between 5 to 19, and a mean height. And second one is height underscore country CSV5. This one will import above 170 countries that are available, and a sex will be boys and girls. A years will be 1985 until 2019, and age group will be same as the first one is 5 to 18, 5 to 19, and a mean height. So okay, next, this is a subroutine for the height. First, there's an option between which sex do you want to compare your height with, or compare height between country. If you want to compare your height, it will ask you which sex you want to compare. There's a boys and girls option to choose, and you need to input your height and your age in each option, and it will display the graph of your height compared with a mean height of the world. And if you choose compare height between country, and you want to see which country is available, it will show the country that are available to choose. If you don't want to see, just input no, and it will let you input first country and second country that you want to compare with. Then you input your age that you want to see, and it will display a graph differential between two countries. For this one, this is output. You can compare your height with the world population of the same age as and the same gender. The topic of the graph will show the data from the user input. So the red line is your height and the blue line is a mean. This graph shows where is your height for compare in a world record. And in this slide, as you can see the development that are different between the countries. It shows that the height for this age and gender is increasing every year. And next, I will show you the program. So when you run a program, it will ask you what option do you want to choose. I choose height. If I choose would compare my height with sex, boy, and in centimeters, I enter 120. Enter your age, and it will show the output of your height. This one. Yeah, this one, as you can see, your height is 120. It compares to a world height in the same gender and same age. It looks something like this. And the next one, I will choose another option. So the next one, I will choose the option 2. So when you run a program, I will choose height option. Option 2. With sex, I want to compare the boy. If you want to see the regions, just type yes. And I will choose the first region is Japan. And the second one to compare with is China. and I input age if yes. And the output of this program will be like this. As you can see for this one, let's take a look at the output. We can see that the share of Japan is lower than that of China, which shows that the most of population in the year 8 years old age group in Japan is lower than that in China, and it can be seen that the trend of children high position is increasing every year from the annual data of the x-axis of this chart. Next, I will show you the detail of the program. So, next is a program. The program starts by reading two CSV files using pandas height world .csv and height underscore country .csv, which contain the average height data of boys and girls from different age groups and countries, respectively. The user is then prompted to choose whether they want to compare their height with boys or girls and to input their height in centimeters and age. If the user chooses to compare the height with boys, the program retrieves the data for boys of the same age group from the f underscore height using the log function and plus line graph showing the average height of boys for each year. The user height is also plotted on the graph. So as a red dashed line, if the user chooses to compare the height with girls, the program retrieves to the data for girls of the same age group and posts a similar line graph. So if a user chooses to compare the average height between two different countries, the program prompts the user to choose the sex they want to compare, then ask the user, would you like to know which regions are available? Then if user type yes, the program will show the country that's available and user choose the two countries they want to compare. The user is also asked to input the age group they want to compare. The program then retrieves the data for boys or girls of the same age group from the f underscore height underscore country for each country and plots a line graph comparing the average height of the two countries for each year. The graph also includes a legend indicating which line represents the country, and this one is a show the graph mean and marks the data. So we figure size is we input 14 and 8, and it will shows the x-axis is a year and y-axis is a height. Okay, we'll go in the next one.
This is some of character data table you can see from a picture below. We need to compare sex, men and female in years 1980 to 2018. Next. This function one first start we get user info function get the gender value to check if the gender is correctly entered. If correct, then go to receive character type, but if it wrong, escape up an error message and then loop back to get a new gender value. Next, receive the cholesterol type value to check if it puts correctly. If it is connected to cholesterol receptor, but if it wrong, it gives an error message and goes back to get a new cholesterol type. After that, receive a cholesterol level to check if it run correctly. If correct, show confirm paid. But if it wrong, it's pop up an error message and loop back. Finally, return a gender, cholesterol type, and cholesterol level to continue using and end. Next. In function 2, start check cholesterol function. First, get user data from function get user inform function 1, such as gender, cholesterol type, cholesterol level, and then send it lead to evaluate cholesterol level from the file cholesterol.csv, make the cholesterol type, then put it in the variable and calculate difference between user and average cholesterol level. Next, put the data in the .csv file to calculate the percent difference and show result of cholesterol level and percent difference. Finally, plot the graph to display and end. And next, this graph, as you can see, it show average to cholesterol level comparison in 1980 to 2018. As you can see from slide, the graph was decreased every year in the graph between 1980 to 2018. It show average total cholesterol of men it decreased about 0.15 and average total cholesterol of women decreased about 0.22%. And next, we go to detail about program. Choose number 4 cholesterol and choose option 1, check your cholesterol level. Male and total cholesterol level. Please enter your cholesterol level 4.51 and please gender again. Yeah. This gap, your total cholesterol level, it show your total cholesterol comparison in 1980 to 2018. As you can see from the graph was decreased every year. It shows that people health is getting better every year. In the gap between 1980 to 2018, the gap is decreased 0.2%, and your total cholesterol level about 4.51. And next, the program start by importing the necessary library pandas for data manipulation, matplotlib by Python for visual lesson, and CSV for reading with writing CSV file. The program lists cholesterol data from CSV file called cholesterol.csv using the pd_raise CSV function from pandas. The data is stored in the pandas data frame is called code. The program define function called get user info, which prompt the user to enter their gender, cholesterol type, and cholesterol level. Is validate the input and return the greater information. The program define a function called check cholesterol, which call get user info function to get user information. It then calculates the average cholesterol level for the user gender, cholesterol type for data frame. The program define function called compare cholesterol, which allow user to compare cholesterol data between male and female. Is prompt that user to select cholesterol type and plot a graph compared to average cholesterol level between two gender. The program define to graph plotting. Their function use matplotlib.pyplot to create line based on the program call the compare cholesterol function first and then the check cholesterol function.
Okay, done. Next.
Okay, the next subroutine is about growth data of blood pressure. For the picture below, this is some of the data that we collected in years 1925 to 2015 in about 6 men and women. Next. Okay, I will show the function of this blood pressure graph. First, receive a gender. If you will need to input about women or men. If you input women, it will go to receive blood pressure from user. If no, it will be a man. If yes, it also receive blood pressure from user. But if you answer invalid, it will go to display error message and ask you again to complete a user gender. From receive blood pressure from user, next it will plot the graph in average and compare between your blood level and your average blood pressure graph. Next function, it will be compared about kind of blood pressure from women and men. First, you need to typing a kind of blood pressure. It is a systolic or diastolic. But if you answer a systolic or diastolic, it will plot pressure comparison graph between men and women in years 1975 to 2015. But if you answer invalid, it will be display error message and ask you again to complete the true blood pressure type. From this graph, it will be an example of compare your blood pressure between mean of the blood pressure. First, it will ask you what sex you want to compare with. In this graph, it will be men graph average. And it will be asked you about your blood pressure value. My blood pressure is 126.5. And will be plot the graph and show. Next is the same from the first graph, but the graph, the sex is a woman. If you ask you again the program, what sex that you want to have compared with men or women. This graph is women average. And you need to enter your blood pressure value again. From this picture is 120.5. I will show the example of function 1. Run the program and select number 3, blood pressure. Select number 1, men. Enter your blood value is 126.4. We will show a graph like this. This graph is showing the year between 1975 to 2015 from the data that we collected. Next, I will example a second function. Run the program again. Select blood pressure 2. This you need to typing about the kind of blood pressure, about systolic or diastolic. This will be systolic. And we will show the graph of systolic blood pressure comparison graph between men and women. On the graph below, it will see women have a lower blood pressure than the men. Next in the program, first we import pandas, matplotlib, totally, and CSV from dev BP. We input a sex to ask what sex to compare with. If sex men, it will be go to give you enter value, but if sex is woman, it will be enter value too from the program. But if you doesn't put input men or woman, it will be invalid input. Please answer men or woman. It will be shown in the message ask again. Next, in the function to def compare BP, this will be ask you about blood pressure type that do you want to compare about systolic or diastolic. If you type systolic or diastolic, it will be show the comparison graph. But if you input about invalid input, it will be error message and ask you again to input true blood pressure type.
You can stop record.
Okay, so now in the final stretch, we will present the subroutine call trees. So basically the overview of the program. So we start in the main.py file, of course, and we ask for some user information. And the user information is to choose between BMI, height, cholesterol, and blood pressure. And then we will run the relevant functions for that. When we have collected all the data from the user, we will display the graph data. And in all of the graphs, we have an automatic placemaker, so the user knows where on the graph they lie on. Yeah, that's it.
For the expected result of this project is to make the user compare compare their own data with statistics from 2020 by displaying data points in graphs. Then see if you have abnormal status values, so they can adjust their consumption and exercise. Also, we include data going back further in time as well as more recent than 2016. This would result in the user being able to see how these different health factors have changed throughout the years and future probabilities in order to be prepared to cope properly. Thank you.
Thank you.
Thank you.